Hello everyone, today we'll see a complete implementation of Saga Choreography. I have already created a multi-module Maven project. So first we will understand the high-level flow of the system and then we will understand the low-level implementation with a complete code walkthrough. So before the demo, we'll also see how to set up Kafka on local using Docker. So if you are not aware about the Saga design pattern, I recommend you to watch the previous video. You can access it from the top right corner of your screen. So if you have already done that, then let's continue with our today's session. In this project, we have multiple modules representing different services of a distributed system. So here we have order service that handles the order creation and status tracking. Then we have inventory service that manages the product stock and availability. And we also have a payment service where we simulate the payment processing. All the shared components between multiple services is placed under common-utils, which will hold the shared Kafka events and constants. Now, before we deep dive into the low-level implementation, let's first understand how the request or data will flow in this system. The saga of local transactions will begin when a user submits an order. It will reach the order service with the details such as product ID, quantity, and user ID. Now, based on the data received, the order service will create an order in the database and then publishes an order created event to its dedicated Kafka topic, which is order_created. Here, order service acts as a producer for order created events. We'll discuss the event structure and payload during low-level discussion and code walkthrough. Now for this particular order created event, we have a consumer listening to order created topic, which is inventory service. So as soon as the order service creates an order created event, inventory service will listen to the Kafka topic and consumes it. Then it checks if the stock is available and then deduct the desired stock from inventory. And after doing that, it will publish the stock confirmed event to stock confirmed Kafka topic. In case the stock is not available, then it publishes stock unavailable event to its dedicated topic. Now both stock confirmed and stock unavailable events have different consumers. Stock unavailable events will be consumed by order service, then order service will mark the status as failed. And on the other hand, stock confirmed event is consumed by payment service. Now comes the payment service in action. It starts processing the payment based on the amount and user details. Now, if the payment is not successful, then it publishes payment failed event to payment failed topic. And if the payment is successful, then it publishes payment completed event to payment completed topic. Now, inventory service is listening to payment failed event, and based on the stocks which were reserved earlier, it will be releasing back those resources to the inventory. On the other hand, order service is listening to both of these events, and depending on the event, if the payment is failed, then the order is cancelled, and if the payment is successful, then the order is marked as confirmed. So this is the complete flow of our system. So after understanding it completely, you can even add other services like notification service to communicate the order status and shipping service to handle the confirmed orders post-processing part as well. Now, if the processing flow is clear, let's move ahead with the code walkthrough and low-level design. You can pause the video anytime and complete the implementation of explained part and then move ahead. Always remember, there is no replacement of hands-on practice. Watching videos is fine, but you need to implement it to understand it better.